So the third type of factoring is called factoring by sum and product. And we usually do the factoring by sum and product when we have a trinomial. Okay? Now trinomial is quadratic green terms. Remember guys, this will only work with quadratics. It won't work with anything else. So if you have cubic or whatever to the power of 4, it's not going to work. It has to be a quadratic. Okay?
You use power of 2?
Power of 2, that's correct. So in order for me to factor with a trinomial, I have to do sum and product. Okay? So when we're talking about sum and product, first of all, this is standard form. So this looks like this. Correct?
Yes.
Okay? Now can you tell me what is the value of A? 1. Okay. What's the value of B? Negative 10. Right? It comes with a sign in front of it. What's the value of C? Positive 25. Good. Now it's important to know this because you see that green sheet that I have given you, that lime green sheet. That lime green sheet is going to help you with, it's going to help you with, are my numbers going to be positive? Are my factors going to be negative? Which one's going to be positive? Which one's going to be negative? So this is what's going to, this is going to help you. Okay, so I'm gonna demonstrate this, but instead of using the green sheet that I've given you, I'm gonna use this sheet because it's already posted on the board. It's exactly the same. Okay, so we're looking for two numbers that multiply to C. So it always multiply to the value of C, which is your last term. So multiply to 25. And then at the end, we want them to add to negative 10. Okay? So we're going to look for factors of 25. So what multiplies to 25?
Negative 5 and negative 5.
So let's start first. Before we pick our, if it's negative or positive, let's look at that green sheet that you have in front of you. The p-value in our case is negative or positive? So since the b is negative and c is positive, that means I have to look here. B is negative, c is positive, so that means both factors have to be negative. Okay? So give me two numbers that multiply to 25. So they're going to be negative 5 and negative 5? Okay? What else? Give me more factors that multiply to 25. 25 and 1. Okay? You always have to remember that that whatever the number is times itself, times 1, sorry, is going to give you that. Okay? So it's always an option. Alright? Now, these are the only factors of 25. There's nothing else that multiplies to 25. Okay? So out of these two options, which option adds to negative 10?
First option.
The first option. And that's why these are my factors. Because the first option, negative 5 plus negative 5, is going to give me negative 10. Do you guys agree with that? So this option is not useful for me. So it doesn't hurt to write it, but it's not useful. Okay? So now I know that my factors are negative 5 and negative 5. So to factor this, I just write y equals x minus 5 times x minus 5. Done. Okay? So, you're always looking at B and C, and you're always asking yourself what two numbers multiply to the last number, C, and then add to the middle number, which is B. Okay? Alright, so, what am I looking for? Two numbers that multiply to what and add to what? Multiply to negative 30 and add to 1. Okay? B is, what's the sign of B?
Positive.
What's the sign of C?
Negative.
So if I look here, B is positive and C is negative. That means my large number has to be positive and my small number is going to be negative. Okay? So let's look at options. What multiplies to negative 30? Or what multiplies to 30? Let's think about 30.
6 times 5.
6 and 5, what else? Now remember, the large one has to be positive and the small one has to be negative. This is what I just read from that sheet, right? So that means it's going to be 6 and negative 5.
10 and 3.
15 and negative 2.
10 and 3.
10 and negative 3. You're gonna be having problems with this if this was a 29. You guys are not gonna be able to find it because you're not thinking that the number by 1 is gonna give me that number. You're always forgetting that. And a lot of people have problems with this. A lot of people forget this. Okay? Alright, so out of all of this, which factors add to positive 1?
First one.
The first one. Okay? So I don't have to worry about the rest. My answer is going to be 6 and negative 5. All what I have to do is I have to set it in brackets with x plus 6, x minus 5, and it's done. Okay? So, what do we call this form in the red? What do we call that form? Standard form. What do we call this form? Factored form. So what I did right now is I went from standard form to factored form. And the process is called sum and product. I'm looking for two numbers that multiply to my last term and add them to my middle term, and then I'm factoring. Are we okay with this?
Miss?
Yes.
You mean the second one is not correct? Instead of 6 by minus 5?
15 plus negative 2, that's 13. Right? If I add 15 and negative 2, I get 13, right?
What is like 15 is 15.
My middle term is 1.
Times 15 is 30.
It's not 15.
It's 15, so 15 doesn't work.
So, you list all your factors, but you're gonna only one of them is gonna work. Right? Because only one of them is going to add to 1. 6 take away 5, that's 1. 15 take away 2, that's 13. That's not 1. 10 take away 3, that's 7. 30 take away 1, that's 29. So none of these is going to add to 1 except the first one. Okay? Alright. Are we okay with the sum and product? So let's take an example of the back page, which is the one where you have to do multiple or mixed up factoring. Okay? So what if I have this? So that's E on page 9. Always you're gonna ask yourself the question, do I have what? A common factor. That's the first question you're gonna ask yourself, no matter what kind of factoring you're doing. Okay? So in this case, do I have a common factor? Do I have a number or a letter that I can divide by each term?
Yes.
What is it? 3. I can divide 3. I can divide 26 by 3. I can divide 39 by 3. Right? So 3 is my greatest common factor. Do we all agree with that?
Yes.
Do we remember that I pull out the 3 and I divide each term by 3? You remember that from the first lesson of factoring? Now we're going to simplify. And I don't want to forget that I have my GCF at the beginning, and then I have my leftovers in the bracket. We remember that, right? I don't get rid of the 3 because the 3 is part of my equation. Okay, now, what do I have in the bracket? A binomial or a trinomial? Trinomial. Okay, so I have a trinomial. That means if I want to factor, I'm going to have to factor using sum and product. This is the only way I can factor a trinomial. Okay, so I'm looking for two numbers that multiply to and add to negative 12. Now I want you to look in your green sheet and tell me if B is negative and C is negative, what would my outcome be? What would my factors be?
Large number gonna be positive, small number.
That's right. Large is going to be negative, small is going to be positive because I'm looking at B is negative and C is negative. Okay? So, give me two numbers that multiply to 13. I don't have that many options. What is it?
Negative 13 positive 1.
13 and 1, right? And because I said that the large has to be negative, so it's going to be negative 13 and 1. I don't have any other options. What does negative 13 plus 1 add to? Negative 12. And this is what I'm looking for. If it doesn't satisfy the second condition, it's not going to work. Right? That means you've done something wrong. Go back and check your work. Okay? So, now, all what I have to do is A minus 13, A plus 1. I'm done. Right? So, no, you can put A plus 1 and then A minus 13 is going to give you the same. If I want to check my work, and this would not be on the test, I wouldn't, like, you don't have to put it on the test. But if you want to know, okay, I have about half an hour left, what do? I can check my work, right? So the way that you can check your work is work backward. Okay? So what we did here, from here to here, what do we call that process? What's the question asking you?
Factor each.
Factor.
Going fully.
Right? So you're factoring. Going from standard to factored, it's called factoring. What's the opposite of factoring? Expanding. So if you want to check your work and you have time on your hand and you have nothing else to do, you can expand. Right? Because expanding, which is the FOIL method, right, is going to should give you the same answer. So let's try it, just for fun. So, check the work. How do I expand this? First, I have to multiply the bracket, right? Okay, so multiply the bracket. What do I multiply?
8 times 8.
Which is a squared. I leave the 3 outside. Yep.
8 times 8 is plus 8.
Mm-hmm.
And 8 times 13 times 8 is negative 13. And then
13.
times 1 is negative.
Good. So you see my 3 still outside for now. Now what do I do?
Now collect.
Like terms.
You can collect like terms inside the bracket. So plus 1a minus 13a. What do I get? Negative 12a. Okay. What's my last step? We call that distribute, right? Distribute, distributive property. So I multiply that 3 in. So I'm going to get 3a squared minus 36a minus 39. And is that what I started with? That's what I started with. It's not math. Right? It's math. It's a process of knowing what you're doing, knowing what is the backward steps. Okay? Knowing your way back home. This is what I call. Okay? And understanding that if you're retracking your steps, you're gonna get back to where you started.
Going back home is easy.
Yeah. Are we okay with this? Anyone have any problems with factoring sum and product? Okay.
Yes.
Yes.
If we have a binomial.
If we have a binomial, then most likely it's going to be a difference of squares. Okay? So, give me an example.
48x squared minus 27y squared.
Okay,
Because
we have a binomial, but what's the first question you're gonna ask yourself, no matter what you have?
Do you have the common factor?
Thank you. Do you have a common factor? I'm gonna keep asking you this question, and you're gonna ask me back the question, do I have a common factor? Do I have a common factor? Is there a number that I can divide both 48 and 27 by?
Yes.
What is it? 3. Right? How about letters? Do I have a common letter?
No.
No. So 3 is my only common factor. So I'm going to take the 3 out and divide both terms by 3. What do you get when you divide 48 by 3?
16.
And then 9
Y squared.
y squared. Okay? So far, all what I've done is the greatest common factor. Now, I have to look inside the bracket and I have to decide. Do I have a binomial or a trinomial? Binomial. So I can't do sum and product. Forget about that. Okay? Can't do that. Now, if it's a binomial, then it could be a difference of squares. You remember that word, difference of squares? Remember that your 2 check marks that you have to check is both terms are squared terms, and we talked about squared terms, and then there is a negative in between them. Do you see that?
Yes.
Is 16 a squared term?
Yes.
Yes, 4 squared. I can prove it to you. It's right there. Right here. Right? Is x squared a squared letter? Yes, because it has an even exponent. Remember we talked about that? Okay. Is 9 a squared term? Yes, 3 squared. Is y a squared letter? Yes, even exponent. Good. So that's a check mark on the square terms. Do I have a negative between the 2?
Yes.
Good. So I can use difference of squares. And you remember that when I do difference of squares, I set up 2 brackets, one with a negative, the other with a positive, and I take the square root of the first term, the square root of the second term, place it in the second spot, that's a square right there, right? And then my final answer is going to be, what's square root of 16x squared? 4x.
3y.
What's the square root of 9y squared? 3y. Don't forget your y's and your x's. And that's it.
What if there's a positive sign in between them?
Then you can't do it.
When it's like 16x squared positive 9y squared?
You cannot factor that. Because the rule for it to work, it has to be a negative in between them. Right? Yes. No. Are we okay with this? do yesterday? Yeah? And finding the equation from the graph. Okay. So, why do we use the factored form? Why are we so interested in factored form and factoring and doing all this work? Any ideas? Why are we interested? Why are we interested? Let's start with the vertex form. Why were we so interested in the vertex form?
Because it will give us vertex.
So this is, you can find the vertex, you can graph using the step pattern, beautiful. Okay, good. Standard form can only give us what? The y-intercept, which is c, but that's it. We don't know anything else from the standard form. Good. Now, why factored form?
Factor form will give us the zeros.
That's right. When I have it in factored form, I can find my zeros right away. So I'm going to go back to this example right here. Okay? So this example right here. I can look at it, and I can say my two zeros are 13 and negative 1. I'm done. I found 2 points on the graph, and then I can do some work that I don't think you guys have in the video yesterday didn't teach you how to do the axis. You did it? Okay. So this is going to be our next lesson. After I know the zeros, I can find my vertex. Easy. Okay? So the factored form is helpful because looking at the factored form, I can solve for my zeros. And if you guys remember, the zeros are of a quadratic, let's say, right? They're right here. So they're your x-intercepts. Okay? That's why I'm interested. Now the question is, how do I find it? How do I find my zeros from the factors? So to find the zeros from the factors form, zeros from the factored form, what we have to do, we have to set up the y value to 0. Okay? Because remember when I'm looking at the x-intercepts, right? If let's say this is my graph, when I'm looking at the x-intercept, what's the y value at these 2 points? 0. The y value is 0 at these 2 points, right? Because it's on the x-axis. So what I have to do is I have to set up y equal to 0. Don't graph this. This doesn't work. I'm just sketch. Okay? So set up y equal to 0. Now, I'm going to ask you guys a question. If you have a times b, don't write this, and a times b equals to 0, when would this case happen? When would you have a times b equal to 0? What would the value of a be, for example, for a b equals to 0? 0. The value of a has to be 0 in order for a times b to be equal to 0, right? You agree? In order, when you multiply something by something else and be equal to 0, one of them has to equal to 0, right? So if I have 3 times something equal to 0, what would that something be?
0.
If I have 17 times something equal to 0, what would that something be? 0. So one of them, either A or B, have to equal to 0 in order for me to get a 0 answer. Do you guys agree with that?
Yes.
Okay. Now, right here, I have x minus 2 multiplied by x plus 7. So I have a case where I'm multiplying something by something, and I'm getting a 0. So that means, in order for this 2 to be true, either this has to equal to 0, or this has to equal to 0. Do you guys agree? It's the same idea as A times B equal to 0. So either A has to equal to 0 or B has to equal to 0. How many of you understand that part? Just 3? Okay. What part do you guys are not getting?
Is yx plus 7 is equal to 0, why is
Because in order for this equation to equal to 0, this has to equal to 0, the x minus 2, or the x plus 7 has to equal to 0. It's like when I was saying here, A times B is equal to 0. For this to happen, either A has to equal to 0 or B has to equal to 0. Right?
Right.
Do we all get that though? Okay. So in this case, I have to go back here and set each factor, each bracket to equal 0. Now, when would x minus 2 equal 0? Solve for x.
X is equal to positive 2.
So bring this over, and that will be x equals 2, right?
Yeah.
So when x equals to 2 minus 2 is going to give me 0, right? When would x plus 7 equal to 0?
X is equal to negative 7.
So your two solutions for this, your two x-intercepts are 2 and negative 7. So if you're going to graph your x-intercepts here, these are your two zeros. Okay? Now, which direction is this graph going to open? Up? Why up? Yes, but why?
the minus should down.
Because of the first x.
What's the A value? No. What is the A value? The A value is right here. What is your A value?
1.
It's 1, right? Because it's invisible, right? The A value is right here. It's outside by brackets, okay? A is 1. That means it's positive. That means it opens up, okay? So my graph, the sketch of my graph is going to be like this, right? Now, I don't know exactly where my vertex is yet, but this is what we're going to be learning later on. Tomorrow or today, we'll see, is how do I find my vertex knowing the 2 is here?